Okay, hello students. This is Algebra 2, Unit 4. I am Illustrative Mathematics curriculum where I'm going to walk through the students' task 7.1, that is lesson number 7, 7.1, 7.2, 7.3. The learning target here is let's explore the ages of ancient things and I can use, so at the end of the lesson, you need to know you need to use half-life of an element to calculate how much of the element remains over time. So let me go straight away to the 7.1. So first question is a colony of microbes doubles in population every 6 hours. Explain why we could say that the population grows by a factor of a 6 root 2 every hour. I want you to pause this video and see if you can figure out on your notebook. So I'm going to make a visual understanding of this. So a colony of microbes, let's see, this is a colony of microbes and these are all microbes. And what are microbes? Are tiny creatures, living things which are not seen by the naked eye. So it has to be seen only by the microscope. So maybe the bacteria, virus, okay, then protozoa, fungi, algae. So these are all the microbes that we in our daily life. So there is a colony, and what it says is that means this colony, which is let's say this is a colony in the beginning, and every 6 hours. So I need to make a table. So let's make a table. So let's make a table. So in the beginning, it does not tell you what was the population of microbes in the beginning. So I'll just take one example and say, let's say there was 100. So I'll make my own. So 100 microbes in the beginning. So so in the beginning, so I can call this is, let's see, H, uppercase H. Now what does H stands for is a number of six 6 hours period. So I'm going to write here H, even though they did not give us. Let me write it one more. This is H stand for. So what is H is number of 6 hour period. What it means is if H is one, let me write here. Let's see. This is one. So this is H is one here. Okay. And in the beginning, imagine I just consider that there were 100 microbes, and then this represents m of h. It means the how many microbes after 6 periods of 6 hours of 6 hour periods. So that means if it is one 6 hour period, that means this is 6 hours here. So that means this thing 100, because it says doubles, so this will be there will be a growth factor which will be 2 because it doubles, so 100 becomes 200. Now, this growth factor is for 6 hours. So for h equals 1. So if h is 1, then what is the number of hours? It means h is 1 means 1 6 hour period. H is 2 is so that means there are two 6 hour periods. So what basically it means is this is 6 hours, and this means it will be 12 hours because 2 times 6 is 12 hours. And if I choose 3, it means there is 2. So there are three 6 hour periods. That means 3 times 6 is 18 hours. So what I'm trying to say is that in between there are hours this way. See, so I just did not put them. It means here h is, let's say, the lowercase. So this h is the uppercase, sorry, lowercase is number of hours 1, 2, 3, 4, 5, and 6. So the moment you get 6 hours, it means the uppercase h is 1 hour. So is this h is 1. So I'm making this even though the question is easy, but I feel like to show the visuals to clearly understand what's happening. So for every 6 hour, the period is 2. Now, when you say, sorry, the growth factor is 2 means it is 1 plus 1, which is whatever the original one, which is 100%, plus, so that is a growth percent increase of 100%. So 1 is 100%. Now the question is asked, explain why we could say that a population grows by scale factor of this. Now what that means is we want to know for every hour, like this is for 1 hour. So this means we want to know what is the factor here, what is this number, this then again what multiplies each hour. So this means each hour what is multiplied. So each hour, so there will be 6 of them. You can see very clearly see. And if you don't know, let's say, imagine we don't know this. I'll call it as B. This is B. This is B. B is a growth factor for every hour. I mean, for because from 0 to 6 period, that means this to here is 2, right? That means 6, the b is, that means b times b times b times b. So this all should give you 2, because 100 becomes 200, right? So that means this 100 then that is multiplied by some number, whatever that is, we'll see now. So therefore you get b raised to 6 is 2, and by radical definition, this is 6 root of 2, which is also written as 2 raised to 6. That's it. Sorry, 2 raised to 1, 6. Now 2 raised to 1, 6 is also, so the question was asked, is this really the scale factor? To give the reasoning, and the reasoning is S. The reasoning is you can either do say, hey, for every hour, let B be the growth factor. That means from 0 to 1 6 hour period, there are 6 factors, the same factor. So you have to write this, multiply itself 6 times, which will get B raised to 6, and you get the answer. Now, what is that basically means 2 raised to 1 6 is thing I worked out on the calculator. If you put 2 raised to 1 6, the E is 1.22, then 1.12246. So you can check this. Now, what does that basically means? It is 1 plus 0.12246, which means this is 100%. This is multiply and divide by 100. So this piece will be 12.24% increase. So this is the number which is percent, because remember the growth factor, when you write exponential function a into b raised to x, so this is that revised in the beginning we had 100, and the factor, this factor is the uppercase for 6 hour period. That means we saw it is 2, and the x, so that means this is 2 raised to h. This is for the, this is like a m of b. So this is m of b. So this is for each 6 hour period. But then yeah, if you want to write the equation also for the uh, each hour, then you can see clearly from here. I think there's a lot of stuff what I wrote here. You can see the every time. Let me write here. So remember the h number of hours h is the lowercase h. I can write is 6 times the how many number of 6 hour period. That means the uppercase h. So the h, when you divide by 6 both sides, you get h over 6. So that means we can create another function, number of microbes with each hour, like this way, and we can create a function. That means in the beginning you had 100, And the growth factor that we got is 2 raised to 1. So this is what the growth factor, which is half, which is 2, sorry. So it's 2 raised to 1 sixth. So 2 raised to 1 sixth and raised to h. And so this is of course, the question wasn't asked us to write down, but I felt to show right here so that we are on the same page to get an idea. So for every 6 hours, the growth percent increase is 100, but then we saw for every 1 hour, the percent increase is just 12.24. So let's go to the second question. So the second question about is asking a bacteria population decreases by a factor of half. So they already gave us for every 4 hours. So this is the B. I use it like uppercase, and this is for every 4 hours. That means I can make a table this way and say, okay, so this is like every 4 hours. This means 4 hours, and this is the H, uppercase H. And in between, I'll put three of this. So, of course, in the beginning, maybe there was maybe 5,000 population. Bacteria was 5,000, and this is H is number of, so this stands for number of 4 hours hour period. And this is the bacteria. So B of H. H is so the population of bacteria depends on how many 4 hours period is done. So from here to here, this one question says there is a decay factor. So there's a B is decay factor, which is half. Now instead of half, let me use it like a 0.5. So this is 0.5. That means what does this 0.5 is 1 minus 0.5, which is 100%, and minus that's 50%. That means there is a percent, 50% stays and 50% decays. So this 5,000 now will become 2,500, half of. So what about, so this is for every 4 hours. The question is, they're asking us, explain why we could also say that the population decays by a factor. What is this? So let's check that piece. What that means to you? Now, if you see the table, visuals are very clear. You can see there will be here. I will put on top 1 hour. So there is 1 hour, 2 hours, 3 hours, and then comes 4 hours. So the 4 hours is one h. When h is 1. So when h is 1, it is 4 hours. So that means now we need to know from in between this one. So that what is this number? We need to know one that multiply 5,000. So then again, that number multiplies again the same number multiply itself. Can it multiply itself 4 times? And we don't know that, right? So we'll call this as B, uppercase B. So there are four of them, B. So B raised to 4 will be from here to here because that's like half, right? So B times B times B times D is lowercase b. So this is 0.5. And using the definition of radical, we get B is fourth root of 0.5. And the question was right here. So this is same as saying, okay, the decay factor is and which is 1/2. So and that's it. So either this also is correct, both are correct. This is by definition, and you can all, of course, they are both same, or you could also write this as a half raised to 1/4. Now on the calculator, if you plug this in, you end up getting 0.8408, something like that, 0.8. So which is almost like I will put it like 0.8. So that means this is 84% retained. So how much how much of the population remains is almost 84% of the original population of bacteria. That means you lose if you check this from 100%, if you take away 84%, you get 16% loses. So there is a 16% decrease in the population of bacteria every hour. So this is a decay factor for every hour. It means every time you just you multiply, and that number is of course 0.8408, and that takes care of this problem. I hope I understand. It took a long time, but this concept is so important. You can create the exponential function too. Remember this? So in the beginning, I said, okay, the population, the bacteria for every, let's see, age stands for number of 4 hour periods. So that is 5,000 is what you had, and then the growth factor from here. This is 0.5, so 0.5 raised to h, uppercase h. And now we can write also this for every hour. That means this way, every each hour it will be lowercase, and that will be 5,000 times 0.5. But this time, remember that the h, the lowercase, the number of hours is always 4 times number of 4 hour periods. So if you divide by 4 both sides, you get h is this. So this answer becomes, so this is h by 4. How beautiful math is. Okay, so it's like creating also, not we didn't even just do the kind of understanding what is decay factor and the growth factor, but we also showed the visuals, how it works, and then you saw how the growth factor, what is the percent increase, then you saw the radical, how I tried to show this. Then we created the two different ways, the exponential functions, and I hope that takes care. So let's move on to 7.2. Question number 7.2, radiocarbon dating. So here's a question. Carbon 14 is used to find the age of certain artifacts and fossils. It has a half-life of 5730 years. So if an object has carbon 14, it loses half of it every 5730. You can pause the video and also check if you can complete this, the whole thing. Would appreciate. And let's move on. Okay, so here's the question. At a certain point in time, a fossil had 3 picograms. Now, what is picogram? 1 trillionth of a gram. So one. So 1 picogram is 1 trillionth of a gram of carbon 14. Now, remember, carbon 14 is an isotope of carbon. Okay, so the question is complete the table with the missing carbon 14. So what I'll do is here is the table. This is what we are supposed to do. And of course, they gave us in the beginning, in the number of years. So the fossil was found, and the fossil contained in the beginning 3 picograms of carbon 14. Then they asked us, hey, how much of carbon retains after 1900, how much is after 5730, and if there is a 0.75 picograms of radioactive carbon 14 in the fossil, then how many years must have passed by? So so the question here is, oh, this is the question. So complete the table. So what I'm going to do is let me copy this. So let me draw this. What is he saying is a fossil is being found. First of all, let's talk about carbon. So the original carbon is carbon 412, and also there is carbon 14. Now, carbon 14 is isotope of carbon 12, but this one is unstable. So they are carbon. So this is radioactive element which decays due to instability of the atoms. Basically, the atoms break down, and the amount of carbon 14 decays. So how much it decays is already given to us. It says So let me draw the figure. So let me, this is, so let's put it like this. So let's see if you, the fossil, we don't know how much was the, it was 3, right? They gave us a 03 was the original. And after 5,000, now this is 5730, the number of picograms, that means this one, after this one, there is a decay factor. So there is a decay factor which is, so decay factor that is B. So this is B equals 0.5. So this is a decay factor. That means this 3 will be in after 5730, this will be 1.5. So that means in the table, you'll see, if you see here, we can put this is 1.5. So from here to here is 5730. So this becomes multiplied by 0.5. Now we can also see from here to here how many years passed by, but then by just looking at it, you know this one, 1.5. How did we get 0.75? It's because of 1.5 if you divide by 2. That means you are multiplying 0.5. So that means from here to here, it takes 5,730 years. So from here to here also, it's like you're adding plus 5730, then plus 5730. So if you add, you get 0,641, 11,000. So that's how you get the answer. So that takes care of. So how do we figure out what is this number then? So let's check this out. 1910. If you see this 1910 from here to here, so there is a relation between 1910. I want you to think of what do you think must be this number is related to this number. Of course, it is less than. Then how many of them do you think? So one nine, so 191910 plus 1910. If you add up, you get 9983, and then you add one more 1910, and you get 5730. That means three of these. Let me in between. So let me draw. So it's if this is five. Oh, I already have it here up here, right? So that means here. So what I'm trying to say is here it is. I can break this into two. So from here to here, it is 1910. That is, sorry, this should be 1910, and then again I think I worked out it as 3820. This is 3820. And then, so that means we need to know what is the factor here. We need to know the black number that multiplies three times. See, one, 2, and 3. So this is what we need to find, that B. Let's call it as B. And you can see. Now this is the low up. This piece is the lowercase, and we want to know what is that factor B for every 1910. So if uppercase B is the number that multiplies, so B times B times B, and that gives you uh, the factor 0.5, which is 0.5. B cube is 0.5. Using the radical, you get cube root of 0.5, and this is 0.5 raised to 1/3. It can be also written as half of 1/3. That means each time after every 190, if you put on the calculator, if you put it on the calculator, you end up getting, mm, so you end up getting, So you end up getting this 0.79. So this also is correct, the decay factor, and in the decimal form this. So this actually is 79.37% stays. That means you lose about 81% you lose. So that's about understanding, completing the table. So now I have one more question. So this completes the first part. Second part is a scientist uses the expression 2.5. So this expression, so that means, what do you think is this 2.5 means? What is half means? What is 5730 means? Remember the exponential function is a b raised to x. Okay, so that means in the beginning, so this means 2.5. This 2.5 is number of. This means it is the number of picograms of of carbon 14 in the fossil in the beginning. So when the when the substance got fossilized, so the amount of carbon was 2.5 picograms. Okay. Now, so and what is this? This piece means this uh, this 2.5. That means this 2.5, which you see here. This in the beginning it is 2.5, and then it says what is every 5730. This becomes half, which is 1.25. That's what this means actually. See now. Uh, that means what are you supposed to write? What are these two numbers means? The carbon 14. So this carbon 14 decays by a factor, decay factor half every 5730. So that's all you're supposed to write, that every 5730, the amount of carbon 14 in the fossil becomes half, which is 0.5. So when you multiply by half, that's what you get it. So now the question is, that takes care of the first part. And now there is a second question. The second question, would more or less than 0.1 picogram of protein remains in the fossil today? So now the asking is whether it is less than zero point 0.1 picogram or whether it is more than uh, zero point 0.1 of the carbon 14 stays. Okay, let's see. For this, I'll just try to show the timeline. That means 5730, and this was found 20,000 BC. So this means when I say zero, this basically means you're talking about 20,000 before Christ, but I would say BCE, before Common Era, uh, because the Gregorian calendar we say zero before uh, BC and AD. So that's why I would say it's better to use BCE is before Common Era. Nothing to relate with any religion here. So let's. So that means if I try to use, let's see, I want to make sure we understand this concept here. So this is a timeline, and imagine this is I'll put this as 0 and this is like 20,000 BCE. So that means this will be 10,000 BCE. Okay. And in between we have 15,000 and 5,000. And if this is 5,000, 5,000, that means we are almost 1, 2, 3, and 4. This is where we are. This is 2000 because this becomes 4000. This is 6000. This is I think I mixed somewhere. This is 8000, and then comes 5000. Right. messed up here. Sorry. So that's 5,000. So let me draw. So that means if this is 5,000, that means I have to break this into five parts. So 2,000 will be this one. This is where we are right now, 2,000. Okay. Now, now we want to know, we know that the fossil, the carbon 14 in the fossil gets decays to half after 5,730. Now, if you see this from this piece, we want to know how many of this 5730, because from here to here is because it is 20 from Gregorian in the beginning, that's the start. And if you think 20,000 before and 2,000 after, that is 22,000. So we are here. This is 22,000. But then we want to know because we do know the carbon 14 decays to half every 5,730. So if you do this 5,700, 5,730, 5,734 times, you end up zeros 12, 2, 1, 28, 9, 2, and you get 22,000. Now that is almost like uh, 22,000. That's almost like uh, so this is it's like 20,000. That's like almost close to 3,000. Suppose I say this is 4,000, so somewhere here. So this piece is like a 3,000. So this is because this is 20,000 plus 2,924. I want to know what is this means? Almost approximately 3,000. That's why I'm saying this is 3,000. So that means I have to break this into four pieces, maybe one. So from here to here, I break this into four. Maybe here, one, two, three, and four. So that means you can clearly see this. That means the decay factor from here to here will be half. Then again you multiply into half. Again you multiply into half. And again you multiply half. That's like 1/16th. So that means the decay factor is 1/16th. So that means we need to know, the question was, would it be more than or less than 0.1 picogram? So 1/16th of the 1/16th of in the beginning there was you see this 2.5 picogram was the amount of carbon 14 in the fossil. So it is 2.5, and if you do little maths there, you end up getting point 0.1525 picograms of. Now can you see this amount is greater than zero point 0.1. That means right here, the amount here is the amount, not 2000, not 2000. I'm talking about this piece. This is the amount of picogram is 0.156. So that means the number that this right now we are in 2000 after AD, sorry, yeah, after AD. So this piece, that means this will be, so at this time it is 0.1, that is 22,000. After so many years, that will be 0.1. That means we are just 2,000 here. This is 22,000, right? So here it will be less. That means it will be, now this is smaller to this number, which is 2,000, is smaller to, so this is 2,000 and this is 2,000, 3,000. So 3,000 and this is 2,000 on the timeline. That means this is before, right? So before there will be more here. See, this will be more. So here, so, so whatever this number should be greater than, whatever this will be greater than 0.156, because this is 0.156. So this is greater. So that means it has to be, because the question was asking, would it be more than zero point 0.1 picogram? Yes. because this number is already greater. So 0.1, so this piece will be 0.156 itself is greater than 0.1. So in 2000 right now, it will be 100% greater than 0.1. So I hope that makes that helps because it's very nice to understand how the timeline works. Can you? I hope you get a whole idea of the picture to see what's going on. 20,000 before from here to here is 20,000. This is 20,000, and now we are here 2,000, and so on. Of course, I hope I made sense to you. So that takes care of how to find number of picograms. Or you could also use. Oh, we could have used this. Is what I forgot actually. So I just thought of showing the one before because there were 116. Because okay, I forgot about that. Remember the factor was 116 there. But then here, could we use this? Yes, we could also use what is the mass of the carbon 14? I could say, okay, mass of carbon, or we say, okay, carbon after T this could be is 2.5. That was the 20,000 BC, and then half raised to T is number of years since 20,000 BC, and this is 5730. We could directly put this as 22,000. 22,000. Now, if you want to know very precise, we are in 22,000. Uh, we are in two, 2025, right? So I could write like this also. So this is, then we'll have to write down 2.5 times half raised to 025 divide by 5730 and put it this whole thing on the calculator. Okay, let me see if I can do this right here. 2.5. Okay, if I put this, so this 2.5 times 0.5 raised to the power. So it was 22,025 divided by 5730. See, you get it. So that's greater than 0.1. So we could have done this, but I thought of showing the factor of half, 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 half 4 times to get 1/16th of the whatever that. So hope that makes sense to you. So let's go to the last one. 7.3 half-life of carbon 14 is this, which we already know, and Pythagoras, the whole Euclidean geometry is created by Pythagoras, who lived in the year 602 BC. So I'm gonna even draw the line. Let's see, this is 0. So let's draw the double line. This is 0, and if we are right here, let's see 2000. This is 2000. That's where we are right now. And if this is 2000, and that would be too small. Let's make it a little bigger now. Um, mm, so that means if this is 0, let's make this one as 2000. So if this is 2000, this will be 1000. So then we have 5 pieces, which is 200, 400, and all that. So if I write down 1, 2, 3, 4, and 5, and 6. So this is 600 BC, and this is 500 BC. So this is the period where Pythagoras stays. This is where he lived his life, those years before the common. This is the initial one. Okay, the question is what explain why the age of papyrus. Now, papyrus is a paper which is made from the plant papyrus. So that's why it is called the age of papyrus. With those days, there was no the actual paper that we use. They used to use kind of a material created from some plant. They had their own process to do, and that's what it is. Now, the question now this one had that carbon 14, the isotope of carbon. Remember, carbon 14 is where the protons, okay, the protons and neutrons are they are not the same in the nucleus because this one protons is I think it is 6 and this is 8, so the atomic mass is 14 here. But the one that is carbon 12 is the one that is stable, which has both 6 protons and the 6 neutrons. Just for a quick glance or flashing of chemistry here. Now, now this one explain why the age of papyrus from the time of Pythagoras. That means this one is about half life of carbon 14. Now remember carbon 14. The half life of carbon 14 is after 5,730. So if it is 5,730, this is let's think of this is 600. Okay, from and this we are right here 2,000. From here to here, if you see, we have to add this 600 and this 2,000. So if you add this, you get 2,600. And you can see this 2,600 is if you take the half of the half life of carbon 14, it is 260. If you take it is less than 2 times, I think it is 862. And yeah, so I'm just taking a round one. So 2 is so little less. That means what does that basically mean? Yeah. So the question was explain why the age of papyrus from the time of Pythagoras half of carbon 14 half life because half of carbon 14 life is this and this the total number of years since the Pythagoras lived until now is 2600 and 2600 is 2600 is almost same as half of this. See, it's almost same thing, and that's what the question was. So that means if you want to really check where is 2000, where is this 5730? When you take the half of it is 2862. Now 2862 will be from here to somewhere here. See, so this is that 28 almost close to this one, which is 2,600. But then this is, if you go this way, I don't have enough room to show that 2862. Then if you go this one, which I don't have enough room to show because I can't do this, that means there are two pieces of 2862 that gives you 57320. That means the question is what is the factor from here? So what is the factor from here to here? See? So that means there are two of these which go to become half. So one of them will be, this will be half, which is 0.5. And because there are two, 1 and 2, so I have to say 1 raised to half. So this means it is half raised to. So let me just clean this. So okay, let me finish this. That's the second question. So this is what I wanted to show that for every uh 2000 here, not 2000, but this from here to here. Okay, so I made a slight mistake here. This should be this one. Let me use this from here. So from here to here is half, right? That's multiplied by half, which is 0.5 decay factor, and then again it goes. Okay, that means the one here, this piece, this piece will be I'm sorry. This part I made a slight mistake. This is not half. The big one is for every 5,700 for this is half. So that's multiplied by 0.5, which is half. That is for 5. This is for 5,730. I don't have enough room there. But the pink color that I showed is for half of this one. This is this piece, this one, 0.5 raised to half. So if you say 0.5 raised to half, which is actually, if you work on the calculator, so if you put here 0.5 and go up and put a half, see, it's 70, so it is 0.70, 0.7171. So go back here. So that means this, so this means 0.5 raised to half, which is also half raised to half, and you work on the calculator just on 70, 71, which is 70%, 70.71%. Now, there was a question I asked in the second case is asking you is did Pythagoras? So the second question, the second part is someone claimed that they have papyrus scroll written by Pythagoras. So somebody says they do some investigation of testing and they see the scroll has 85% of its original amount of carbon 14. So there is the scroll. Let's say this is the scroll. This is like how the scroll goes, and then you open up and you roll it, it goes down and down, and that's like a scroll. And somebody says, hey, that's the written by Pythagoras. And because the only reason the person says is because he sees that there is 85% of the carbon 14. But the question is it really true? But then the if you see back when we figure out 0.5 and I worked out 1 over half, we ended up 0.7071, which was 70%. So it's not, it's not 85%. So that is wrong. This is false. So what is happening is only 75% of the papyrus or carbon 14 stays in the papyrus. Uh, And since 70%, this one is less than 85%, as was seen that it was 85% of the carbon 14 in the checked in, so it doesn't match. So you can clearly see this not. So the whatever the scroll that was checked on was not old enough. It was not old enough to have 70%. So I hope you you understood the concept. So the goal is I spend a lot of time explaining is to get the concept clear instead of mechanically getting the answer. So visual learning is more important, and also creating exponential functions. Thanks for watching and stay in touch. So I did not get enough time to do. There was one more there was one more. Are you ready for more about one Gutenberg Bible, which was written in for 1,450 years? And they were saying how much is the amount of carbon 14 stays, but because of the time, I'll just stop here.